Hello there. In this video, we're going to talk about translating and reflecting functions. So I'm here on Desmos. I have graphed y equals the square root of x. Now that's a very basic function in that there's no adding or subtracting. Nothing's happening to the x other than the square root. When you have a very basic function that every other function seems to be based off of, that's called a parent function. So this is a parent function, and we're going to use it to make other functions. So let's start with this. If I take that equation and I add 5 inside the square root, watch what happens to the graph. It moves to the left 5. If I add 6 to the graph, it will move to the left 6. So you can see that this red graph was the parent function, and adding 5 or 6 just moved it to the left. If I subtract 5 instead of add 5, it's going to move to the right 5 units. What I'm going to do here is I'm going to change it to be x plus a, and I'm going to add this slider here to show you that as a gets smaller, the graph moves to the right. And as a gets larger, the graph moves to the left. And that's because if I want to translate, which is to move, if I want to translate a function left or right, you add and subtract to the x inside whatever operation is happening to it. But it works in the opposite way. So if I increase that number that I'm adding, it actually moves more to the left. And if I decrease the number that I'm adding, then it moves to the left. So it's not just this function that it works on, it's pretty much any function. So let's try another function. Let's try x plus a squared. So now we have this parabola here, and I'm going to do the same thing. The parabola says x plus a squared. Right now a is 0, so it's just x squared. But as I increase a, it moves to the left. And as I decrease a, it moves to the right. So if you want to move a function to the left or to the right, you add to the x before any other operation happens to it. And that's why it's in parentheses. So now let's talk about moving functions, translating functions up and down. To translate a function up and down, you add and subtract to the function at the end after everything else has been done. And this one works the way you expect. If I add bigger numbers, it goes up. Big numbers, this is going up. If I make smaller numbers, the number I'm adding gets smaller and smaller, the graph moves down. So adding inside of parentheses before the operation moves it left and right. And that does the opposite of what you think. Adding to increasing, it actually moves it to the left. Decreasing moves it to the right. But adding and subtracting at the end, like this plus a here, does exactly what you expect. As we increase that number, it goes up. And as we decrease the number, it goes down. Okay, I'm going to change my function here to, let's do x to the third. So now let's talk about reflecting functions. What we just talked about was translating, which is moving. Reflecting is mirror imaging a function. Now, if you put a negative in front of the x before it's squared, or before it's cubed, you can see that I mirror image this across the y-axis. So changing an x to be negative before the operation is done makes it flip across the y-axis. And reflection is symmetrical. Everything stays the same, it just flips. In this case, horizontally. And I'll show you another example of that. Let's do an absolute, actually, let's do a cube root. So that's a cube root function. And if I make the x negative before I cube root it, you can see that it mirror images the graph. Now, if I want to mirror image it across the x-axis instead of the y-axis, I don't make the x negative in parentheses. I let that 1/3 exponent happen, and then I make it negative. So you make all the operations happen, and then the last step is to make it negative. So the difference is, you can see I'm putting the negative after everything, and you can see this graph looks the same because that's how it is. So let's try a different graph here. Let's try absolute value of x. So absolute value of x is a V shape, but if I put the negative outside of the absolute value sign, you can see that it makes it go the opposite direction. So reflecting, to recap, making the x negative before you do any operations, that usually forces you to use parentheses, makes it reflect across the y-axis, and making a negative after you do all your operations makes it reflect across the x-axis. That's all for today. Thanks for watching. Have a good day.